Okay, so welcome back to another episode of Python, and today, or just coding in general. Today we're going to be talking about something that a lot of people are not familiar with, or at least not that familiar with. Something called pointers. Okay, something called pointers, and if you have gone through a little bit of C, you're definitely going to know what pointers are. And you're going to say that you're going to hear a lot of people say that it's hard, but today I'll try to get the easiest approach for you to understand what pointers are. And so let's say pointers in general, you can count on them as sort of like, okay, so how do I get to, let's say, LA? And then a pointer tells you, okay, you should point to there. And then that way you get to LA. And so basically it's like a road sign. And it's the same in C. And so I'm going to do a little bit of abstraction here. And let's say that n is going to be equal to 50. What this does is that, first of all, it finds a space in the memory. Okay, we're going to call this a hotel room, because this really helped me understand. We're going to call this a hotel room. And then we're going to put 50 as a guest. We're putting 50 inside of the hotel room. And the hotel room has a room number. The room number is the address. For example, 0 times 100. And then N is kind of like the label. N is like the label. And then you kind of just put a sticker like N. That's on like the hotel room. Okay. And so what are pointers? What are like what is this English? But we can actually give a hotel room, right? You can actually put a pointer inside of it. So you can put an address inside of it. A pointer points to an address. You can put like 0 times 200 inside of it, and then you're gonna the license the room number is still gonna be 0 times 100, and the label is just gonna be, let's say, P. And now what you can do is that, for example, if you call N, right, the only thing you're gonna be able to do is change 50. So unless you explicitly say I want the room number, which is 0 times 100, you're not going to be able to get the room number. You can only change what's inside of it. But with these pointer variables, you can actually, first of all, get the address that you want to change. You can change what address you want to go to. And so that makes a lot of room. And so to really understand the kind of abstract thought of pointers in these hotel rooms, we can have like a normal question. Say A is equal to 95. And then B is equal to A. B is equal to 13. What is A and what is B? And so this is a very classic question. So what our kind of theory is that we get a hotel room, we put 95 inside of it, and then there's like a room number that we don't know about, and then you're putting a label. Label is going to be equal to A. And so for every like variable equal is basically what label are you putting it into, where are you putting it. So B is equal to A, which means that B is going to be another label. B is going to go onto here. It's another label. And then B is going to be equal to 13. So what that means is that there's another place in memory where there's 13. Oof. It's 13. And then you rip B off. And then you put it here. That's all that means. Okay, so if you follow through, then, well, B is going to be 13. A is going to be 95. And so another kind of question is that, for example, let's say A is equal to 0, 3, 4. How about that? And then b is equal to a, and then let's say b 0 equals to 99. Then what is a and what is b? So if you follow through the kind of pointer entire hotel room theory, so you know that we get a hotel room, it's 0, 3, 4 inside, and then the label is going to be a. So b is equal to a, so you're putting the label b onto the hotel room, which is the b is going to be here, and then you're going to change b. Okay, so what is b referring to? You're calling b, you're calling the label, so you're not Drake. That's just something I thought of. So he had a beef with UMG, but that's something I thought about. And then you're calling b, you're calling the label, you're changing the 0th element to 99, so you're changing 034, you're changing it to 9934. So well, there you have it. A and B are both going to change because they're referring to the same thing. Okay, and so there's also some things that I want to talk about. So first, excuse me. So the first thing is kind of in calculus is that it's a very famous, let's say, paradox. That's a rabbit. Here is a tortoise. How do you spell tortoise? Turtle. And so, if a rabbit always goes to where the turtle has stayed, so the previous location of the turtle, and the turtle moves forward a little bit, is it going to be impossible to catch the turtle? And so this actually is not that much of a paradox. It's more of like a logical problem. And so your first reaction is definitely going to be, you're not going to be able to catch the turtle, because what's going to be happening is that you're always going to be moving to the position before, right? And how you're going to catch the turtle with the position before? Well, so here's kind of like an interesting thing. Something pretty interesting is that you're going to get infinitely close to catching the turtle. And so that's kind of like the whole idea of calculus, is getting like infinitely close to something. And then at the point of infinitely close, you basically caught the turtle. And so you're going to say, okay, that's going to cost the infinite amount of time because you're taking infinite amount of steps. However, if we assume that the rabbit moves at a constant speed, and then the first step is going to be moving the furthest, right? And the steps like later are all going to be like teeny weeny little steps. Oh yeah. So I think the original story is that the rabbit goes half of the turtle or something. Doesn't matter. But the first step is going to be the hugest step, and then the second are all going to be teeny weeny steps. And so if the rabbit has a constant velocity, then it means that the time is going to take the longest on the first one, and it's going to get smaller and smaller to a point that it's just going to be 0. And so although it's making infinite amount of steps, it's taking a not infinite amount of time. So let's let that sink in, because that took me a while to kind of figure it out, that infinite amount of steps doesn't refer to infinite amount of times. Another paradox proposed by the same person is that, so for every second, let's see if I can draw a Minecraft arrow. An arrow, for every moment, let's have that, an arrow is, if you take a photo, is going to, with a high enough frame rate, is going to be static. But why is the arrow moving? And so with a little bit of physics training, you're going to say, okay, the arrow has a velocity. The tendency to keep moving. That's the velocity. We're going to call that v. And so the tendency of the tendency is going to be the acceleration. So these few things are not 0. So you're going to be moving. And then what you're going to say is that these are basically the fundamentals of derivatives. And so like let's say of movement, you take the first derivative, dx dy, I don't know how to write that, but, and then it's the velocity. And then you take the second derivative, it's just going to be the acceleration. Okay, and so I don't know how we ended up here, but I might as well finish what I've wanted to say. And basically, limit calculation is basically the same as mathematical calculation. You just do what you gotta do. And then something interesting is that, let's say, lim x approaches 0, x squared times sine x1. I think that's it. And so what does this equal to? So a very interesting way to do this is that, so x squared sine x is going to be less or equal to x squared, less or equal to negative x squared. And so if you take the limit of that, they're going to be equal to 0, and then blah 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 0. By definition of the squeeze theorem, the limit of this is still going to be 0. And so you're not going to have to deal with the positive infinity here, because as x approaches 0, this is going to approach positive infinity. And it also makes sense because this is approaching 0, and 0 times infinity is still going to be 0. So yeah, that's basically it.